Hello everyone. So in this episode, I want to talk about the need for DNS servers, what are DNS servers, and how do the DNS queries are actually resolved by the DNS servers. So what all components are involved in a DNS query, and then we'll also look at the type of DNS records, and later on we'll see how does your system actually send the request to the DNS server in practical and then gets the response. So we'll also try to see some of the examples uh, to actually where this DNS is resolving your whole domain name to an actual IP address. So let's get started. So I think the first thing that comes to our mind is what was the need for a DNS server in the first place, right? So back in the days when the internet was very new, not a lot of machines were connected to the internet, and that's when it was not a hard requirement. So whenever a machine wanted to talk to another machine, they can ask for an IP address from the owner of the machine and they can easily connect with the other machine. But over the period of time when this internet became popular, right, now more and more machines were connecting with the internet. It was not possible to reach out to each and every machine owner and ask for their IP address, and most of the times you do not know what is the IP address of your system these days, right? So the need for DNS server was to have some system in place which can give you an IP address for a particular domain name, and that's why DNS, full form of the DNS, the domain name servers. So these DNS servers are basically a directory for domain names to an actual IP address. Domain name to IP address. And one of the responsibilities or one of the functions of DNS server is to provide the IP address for a particular domain name. Second thing is it can also cache these DNS server names, these host name to an IP address. So we'll discuss it in details how this caching works. And the third one is client side load balancing. Load balancing. So DNS servers can also be used to actually do the client side load balancing as well. So let's see what's the structure of the DNS servers. So this is your root server. This is how DNS servers are organized. Then you have multiple top level 1, 2, 3 and 4, and then these are called TLDs, and TLDs means top level DNS, and then TLDs might have the address to the authoritative server. Authoritative servers. So the components involved in DNS query resolution are 3: DNS resolver, then DNS server. I think that's it. So these two components are involved. So whenever you ask for an IP address, right? Let's say you have your system and you're running a browser and you want to connect to the google.com. So what happens is in the URL you type google.com, and let's assume that you just restarted your system, so you don't have anything cached in your application or in your system, right? So your web browser will first need to ask for the IP address for this domain name to the DNS resolver. So every operating system comes with a DNS resolver. So let's say you have one DNS resolver here, right? So your web browser, correct, you have one process web browser. Now this web browser will ask DNS resolver to provide the IP address for this domain name, right? Now the responsibility of DNS resolver is to actually figure out the IP address, correct? So whenever you connect with the internet, correct, you configure two things. I mean, during the discoverability process, you get two things. One, the actual IP address, and that IP address is the IP address of your system, and the second one is the DNS server name. So your DNS resolver which is sitting in your system, right, will ask the local DNS server. And what is this local DNS server? Local DNS server you get whenever you connect with the internet, right? So whenever you turn on your data or connect with the Wi-Fi, this is configured automatically in your system. So most of the time you do not even know what's the name of your local DNS server. So this DNS resolver will ask for the host name, I mean for the IP address for a particular host name. Now this local DNS server will reach out to the root servers or root DNS servers, root DNS, and if this root DNS has the IP address for a particular domain name, then it will provide the domain name. Otherwise, based on the .com or .in .jp, it will give you the list of top level DNS servers. Now so this was the first step, then it was the second step. Now this local DNS server, right, again will pick these top level DNS servers and will ask for them to provide the IP address for a particular domain name. So TLD, let's say you hit google.com. So this TLD or this top level domain server will reply back either with the actual IP address of that particular domain name, or it will provide you with the authoritative DNS servers which are responsible to provide the data for this. And let's move it somewhere. So now once it gets the list of all the authoritative DNS servers, then it will reach out to the authoritative DNS server. Authoritative DNS. And finally, this authoritative DNS server is responsible to provide the actual domain, I mean the actual IP address for a particular domain. So here if you see, right, this is called the Iterative DNS Query. Iterative DNS Query. Why? Your DNS resolver which was sitting in your system asked for an IP address for a particular domain name to the local DNS server. Now this local DNS server became responsible to actually resolve this host name to an IP address, right? So it first reaches out to the root DNS server. If root DNS has the data, then it will provide the data, but assume that root does not have the domain name mapping, so it will provide the list of TLDs. Now this local DNS server will pick TLDs one by one and will reach out to them for an IP address, right? And based on the request, either these TLDs will resolve the actual IP address, or they will provide the list of all the authoritative servers which might be responsible to provide the actual IP address for this domain name. So your local DNS server will reach out to authoritative DNS servers, and finally the query is resolved. And once the query is resolved, then you get the response. So this is your, so if you see this type of queries where your local DNS server reaches out to every either root level DNS server TLDs and then finally to the authoritative server which holds the actual IP address for a domain name. So this type of query is called the iterative query. And if you see what's the problem in this scene, right? I mean in this design, what's the problem? right now this root level DNS server is getting a lot of requests, right? And then once it responds, then all of the TLDs also will get the response. I mean, will also get the same amount of requests, and then finally the authoritative servers. So here the problem is that every time you are trying to connect with the system, or you are trying to access any domain, right? You are fetching the IP address from the root directly, which is okay. But once you have it, you are again reaching out to the root server. So let's say you cache it here, but still, let's say uh, you are a malicious user, right? Or a, I would say, hacker, and you want to bring down the whole internet. So if you somehow make sure that no root server is reachable, right? So if no root server is reachable, then any DNS server will not be able to resolve your queries, right? So the major design flaw is that all the queries are directly going to root server, and then the TLD, and finally the authoritative server. So to resolve these drawbacks, we had the second type of query, which is recursive query. Recursive queries. Here the components that were involved, right, are still same. It is your DNS resolver, which initiates uh, your DNS query to fetch an IP address for a domain name. Then this is your local DNS, right? Now remember these steps. So now this local DNS server will first reach out to your root DNS servers, right? Now these root DNS servers will reach out to TLDs directly. So instead of giving the list of TLDs back to your local DNS servers, this root server will make sure that it actually fetches the data and then finally resolves it. So, and these TLDs will reach out to authoritative servers, AS. And these authoritative servers will finally respond back to TLDs, and these TLDs will respond back to the root server, and finally root server will respond with the actual resolution of an IP address, and finally this local DNS will respond back to your DNS resolver. So this is third step, this is fourth, and then you got the response in fifth, sixth, seventh, and finally eighth. Now if you see, right, in this whole path, all of these local DNSs are reaching out to the root DNS server, but once, let's say, it gets the record for google.com, right, it can cache it locally, so it doesn't have to reach out to TLDs. And same goes with TLDs as well. Let's say even though root reaches out to TLDs, but TLDs also have some cache, right? So instead of reaching out to authoritative servers, they can cache it and directly respond back with the IP address. So this is another type of query, which is called recursive query. So now let's see, how does a DNS record look like. So your DNS server has name, value, then type, and TTL. So let's first understand what is type. So these types, so A, AA, then CNAME, and finally NS. So this A type record defines that there is an actual mapping. So let's say you have facebook.com, right? So this type of record will give you directly the IP address, and this is for IPv4. Then this is same as type A class, but it gives you IP basics address. And the CNAME is canonical name. So let's say you want to do some host aliasing, right? Host alias. So what is this host alias? Let's say you want your domain available to others is facebook.com, but internally it reaches out to, let's say, facebook underscore -1.com, right? So you don't want users to see this facebook -1, so you can alias it and then create a record of type CNAME and then create another record. So for this type of thing you will have two records. So first one is facebook.com to facebook -1.com, right? And then facebook1.com to actual IP address. So this will be of type CNAME DNS record and this will be of type A. So see, so whenever you get the request, right, it will first check, okay, so this is C type, and then this will check, okay, do I have the address for the canonical name as well? So yeah, it has, because you configured two records, right? So it will return both these records. And finally is TTL. TTL is simply time to live. That means for how long a particular record can be used before it is expired. So let's say this TTL is 1000 seconds. Let's say you configured it to 120 seconds. So this is configured in seconds, right? So let's say it's 120 seconds. That means this record will expire after 2 minutes. But the window between 0 to 2 minutes, you can use this record. So this is how your record looks like, right? Now finally is DNS request response. So DNS is an application layer protocol which internally uses UDP, right? So it is DNS uses UDP, then IP, then data link layer, and finally physical layer. So in DNS you don't actually create a connection as in connection, because you want your application throughput to be as high as possible, right? So you don't want to maintain extra overhead, and that's why this DNS is built on top of UDP, right? So now let's see the request structure. How does the structure look like? So this is how your DNS query record looks like. So whenever your DNS resolver is making the request to the local DNS server, right? So this is how it prepares. So if you see, first 2 bytes are identification, then 1 bit is used whether this is a query or a response, and then the opcode. So let's see in practical how does this data look like. So here I already prepared some examples. So initially I tried to clear my local cache and then tried to hit facebook.com, right? So if you see this type, the protocol type is DNS, obviously, because when I hit facebook.com for the first time and I don't have anything stored locally, so the DNS resolver in my system will reach out to the local DNS server, right, which is my Wi-Fi. So this is what your DNS resolver sends to the local DNS server. So what all things it needs? First, because DNS server might be resolving multiple domain names at the same time, right? So whenever it gets the response, it needs to identify which request this particular response belongs to, right? So in this case, and that's why this transaction ID is an identifier which will basically tell DNS resolver that this response belongs to this particular query, right? And then if you see how many questions it sends? So only one. And it wants to know A type record for facebook.com. So we discussed, A type records will actually give you the IP address, IPv4 address for a domain name. And in our case, the domain name is facebook.com. Right? So now let's see the response for this transaction ID 416E. 416E here. So this is the response. So these flags, if you see here, these are the flags which basically tell you whether it's a request query or a response query. I mean, whether it's a request or response, right? So transaction ID is an identifier, which was this 2 byte, and then you have these flags, and then finally request or response, how many requests or how many records you got from DNS server, right? So transaction ID is an identifier, then you have these. So here the first bit is set, right? And this first bit tells you whether it's a request or a response. So it's set, which means it's a response to an existing request which DNS resolver made, right? And then it says answer RRs 2. That means a single record is called resource record. So that means it's saying that we have 2 DNS mappings for this particular domain name. So first one is C type, and we already discussed this. C type is the canonical name, which is basically alias for this star-mini.c10r.facebook.com. So facebook.com is an alias for this canonical name, and then this canonical name actually has an IP address, right? So that's why it said here 2 RRs in the response. So the first one was CNAME record, and the second one was the actual record, which holds the IP address to a particular domain name. And in our case, the domain name is this host alias. So I think that's it for this video. If you like the content, consider subscribing to my YouTube channel, and see you in the next one.